Hey everybody, so I want to go over one of the problems from the homework. Let's make the screen a little better. Here we go. Scores on a certain intelligence for children between 13 and 15 years are approximately normally distributed with mu equals 100 and sigma equals 15. So mu is the mean, sigma is the standard deviation, and this is the population standard deviation. Will be important for us a little later. So this normally distributed thing is called the bell curve, sometimes called the Gaussian distribution. It has a lot of names. It's really, really important in statistics. It's actually going to be the only distribution we really study. We'll study the t-distribution a little bit. But the normal distribution will do a lot of things for us. So the first question here asks, what proportion of children between 13 and 15, yeah, that's what we're dealing with, have scores on a test above 87? So we want to get above 87. So what I'm going to do here, and what I would do if we have class, is every time I do this problem, I'm going to draw the bell curve. I'm going to draw that normal distribution. So I'd like for Excel to do it for me. So most of the action happens within 3 standard deviations of the mean. So what I did here was I took the mean and I subtracted 3 times 15. 3 times the standard deviation. Then, if you're clever with your Excel, I want to just go up by 1 point on the score. If I then grab this little box and drag it down, you'll see that it auto-completes, and I went too far, but that's okay. Excel can do lots of computations all at once. So we've got 56. We're actually interested in 87, right? So maybe we'll make that one yellow. That one's the one we're actually interested in, right? So then what I'm going to do is I'm going to use a function called norm.dist. This is the distribution of the normal distribution, norm.dist, normally distributed. Then it asks for the x. The x here is this. It's that number. Then it wants the mean. The mean is 101 for every one of these. It wants the standard deviation, that's 15. And then it wants this cumulative thing. Now, this is the only time you are going, this is the only time you are going to see me use this false. I don't use the false unless I'm graphing the bell curve. I then double clicked on that little box and it auto completed. All right, so if I grab these two and I go to insert, I can insert a scatter plot. I really do like scatter plots. I think they're fantastic. And we see my bell curve. You see, I told you that was a lot. I went too far, right? I only needed to go to like 150. Oops. But you can see my nice bell curve. You see right at 101 is the top. And then the 15 says that about 2/3 fall within plus or minus 15. So within these 30, right here in the middle, should be about 2/3 of my data. A lot of my data are right there in the middle. That's what it means to be normally distributed. Okay, so now for this other part. So that's my thing, right? So I want to find the proportion of students that have scores on this test above 87. So if I'm going to put like 87 right here, right? I want to find all the students that are north of 87, that are above 87. So I want to find more than 50% of the students, right? Right down the middle would be 50-50. I want to find over here and I want to go above. So I know I need something bigger than 50. Okay, this is not the right number, this 87 that I highlighted, but actually the way we're going to find it is really similar. We're going to do the norm.dist, and we're still going to use that 87. We're still going to use the mean of 101, and we're going to use the standard deviation of 15. But now when I do the cumulative, I'm going to do the true. Did I do the true? Sorry. I want the true. There we go. That looks much better. But if I look at this, I go 17%. I said it had to be bigger than 80%. I said it had to be bigger than 50, right? Well, 17% is the tail to the left, and I want the tail to the right. Well, the thing about the normal distribution that's really nice is that everything under that tail is 1. So if I do 1 minus the 17%, 17% is going to be to the left of 87, and 82% is going to be to the right. So this is the number that I actually need for this answer. Let's go ahead and submit and show we got it right. Yay! Okay. I'm sorry, I'm getting achievements here. Okay, so then let's try the next thing here. Enter the score in which the marks the lowest 20% of the distribution. So by the way, that number is going to be very close to 87 because 17% was the lowest, right? Maybe a little higher. But I want to use Excel to find this. Okay, so for this one, we're going to use, we're still going to use norm dot, but this time we're going to use the inverse. We use the inverse here because we're going to give it a probability and we're going to ask it to return an X. Before we gave it an X and asked it to return a probability. So I'm going to ask it to find 20% with the mean of 101 and the standard deviation of 15. This time I don't have to do that true or false thing. So I find 88, which checks out with what I said about 87, right? That 87 was very close. So I know that. I think that's right. Last thing that wants me to do is enter the score with the highest 5% of the distributions. So if I blindly go norm.inverse and say, well, I want 5%, 0.05, with a mean of 101 and a standard deviation of 15, I'm going to get the wrong answer, 76. Why is that the wrong answer? Because I want the highest 5%. So what I actually need to do is I actually need to do the norm.inverse, and I need to do 1 minus the 5%. Again, with 101 and standard deviation of 15. So 125 is the top 5%. And I'm copying and pasting. I'm copying and pasting because WebWork demands a lot of accuracy here. And there we go. I got them all right. Okay, guys, keep working hard. You guys got this.